Hello everyone, welcome to Sam Science View channel. In today's video, we are going to listen to a science fact, chemistry behind plywood. Before getting into the video, please watch this entire video, and if you have any science related queries, you can get it rectified through this channel. Now let's get into the video. Plywood is a composite material manufactured from thin layers or plies of wood veneers that are glued together with adjacent layers having their wood grain rotated up to 90 degree to one another. It is an engineered wood from the family of manufactured boards, which includes medium density fiber board, that is MDF, oriented strand board, that is OSB, and particle board or chipboard. All plywoods bind resin and wood fiber sheets, that is cellulose cells or long, strong, and thin, to form a composite material. This alternation of the grain is called cross graining and has several important benefits. First, it reduces the tendency of wood to split when nailed at the edges. Second, it reduces expansion and shrinkage, providing improved dimensional stability. And thirdly, it makes the strength of the panel consistent across all directions. There is usually an odd number of plies so that the sheet is balanced. This reduces warping. Because plywood is bonded with grains running against one another and with an odd number of composite parts, it has high stiffness perpendicular to the grain direction of the surface ply. Smaller, thinner, and lower quality plywoods may only have their plies arranged at right angles to each other. Some better quality plywood products will by design have 5 plies in steps of 45 degree, that is 0, 45, 90, 135 and 180 degrees, giving strength in multiple axes. The word ply is derived from the French verb plier, which means to fold, and also from the Latin verb plico. Now let's see about the history of this plywood. The ancient Egyptians and Greeks cut wood thinly and glued it together in layers with the grain in perpendicular directions as fine wood was in short supply. This is believed to have been done purely for cosmetic and economical purposes, but it turned out to be a great alternative to pure wood as it reduced flex, making it a versatile building material. In 1797, Samuel Bentham applied for patents covering several machines to produce veneers. In his patent applications, he described the concept of laminating several layers of veneer with glue to form a thicker piece, the first description of what we call now as plywood. Bentham was a British naval engineer with many shipbuilding inventions to his credit. Veneers at the time of Bentham were flat sawn, rift sawn, or quarter sawn, that is, cut along or across the log manually in different angles to the grain and thus limiting in width and length. About 50 years later, Emmanuel Noble, father of Alfred Noble, realized that several thinner layers of wood bonded together would be stronger than a single thick layer of wood. Understanding the industrial potential of laminated wood, he invented the rotary lathe. There is little record of the early implementation of the rotary lathe and the subsequent commercialization of plywood as we know it today, but in its 1870 edition, the French dictionary Robert describes the process of rotary lathe veneer manufacturing in its entry, Derolake. One can thus presume that rotary lathe plywood manufacturing was an established process in France in 1860s. Plywood was introduced into the United States in 1865 and industrial production there started shortly after. In 1928, the first standard sized 4 feet by 8 feet plywood sheets were introduced in US for use as a general building material. Artists used plywood as a support for easel paintings to replace traditional canvas or cardboard. Ready-made artist boards for oil painting in 3-layered plywoods were produced and sold in New York as early as 1880s. There were experiments with gluing plywood with phenolic resins, mostly in the form of an alcoholic solution or powder, which however did not provide sufficient accuracy of application. Around 1930, a dry process of gluing veneers to plywood with phenolic resin in form of a film has begun to spread in the production of waterproof plywood. Now let's see some structural characteristics of this plywood. A typical plywood panel has face veneers of a higher grade than the core veneers. The principal function of the core layers is to increase the separation between the outer layers where the bending stresses are highest, thus increasing the panel's resistance to bending. As a result, thicker panels can span greater distances under the same loads. In bending, the maximum stress occurs in the outermost layer, one in tension, the other in compression. Bending stress decreases from the maximum at the face layers to nearly zero at the central layer. Shear stress, by contrast, is higher in the center of the panel and at the outer fibers. Within Europe, basic plywood can be divided into 3 main categories. First is a birch plywood, whose density is around 680 kg per meter cube. Secondly, mixed plywood with density of 620 kg per meter cube. And the third, conifer plywoods, whose density is around 460 to 520 kg per meter cube. Different varieties of plywoods exist for different applications nowadays. First is a softwood plywood, which is usually made either of cedar, Douglas fir, or spruce, pine, and fir, or redwood, and is typically used for construction and industrial purpose. The common dimension of this is 3 feet 11 inch to 7 feet 10 inch, or the slightly larger empirical dimension of 4 feet to 8 feet. Plies vary in thickness from 1.4 mm to 4.3 mm. The number of plies, which is always odd, depends on the thickness and grade of the sheet. Roofing can use the thinner 16 mm plywood. Some floors are at least 19 mm thick, the thickness depending on the distance between the floor joists. Plywood for flooring applications is often tongue and groove. This prevents one board from moving up or down relative to its neighbor, providing a solid feeling floor when the joints do not lie over joists. Tongue and groove plywood is usually found in the 13 to 25 mm range. This type of plywood is often prone to splintering if not handled correctly. And the second is hardwood plywood, which is made of wood from dicot trees like oak, beech, and mahogany and used for demanding end uses. Hardwood plywood is characterized by its excellent strength, stiffness, durability, and resistance to creep. It has a high planar shear strength and impact resistance, which make it especially suitable for heavy-duty floor and wall structures. Oriented plywood construction has a high wheel carrying capacity. Hardwood plywood has excellent surface hardness and damage and wear resistance. Third one is a tropical plywood, which is made of mixed hardwood species of tropical timber. Originally from the Asian region, it is now also manufactured in African and South American countries. This tropical plywood is superior to softwood plywood due to its density, strength, evenness of layer, and high quality. It is usually sold at a premium in many markets if manufactured with high standards. This is widely used in UK, Japan, US, Taiwan, Korea, Dubai, and other countries worldwide. It is used for construction purpose in many regions due to its low cost. However, many countries' forests have been over-harvested, including the Philippines, Malaysia, and Indonesia, largely due to the demand for plywood production and export. And now it is also used in the aircraft building also. High strength plywood, also known as aircraft plywood, is made from mahogany, spruce, and or beech using adhesives with an increased resistance to heat and humidity. It was used in the construction of air assault gliders during World War II and also several fighter aircraft, most notably the multi role British Mosquito, nicknamed the Wooden Wonder. Plywood was used for the wing surfaces and also flat sections such as bulkheads and webs of the wing spars. The fuselage had exceptional rigidity from the bonded ply balsa ply sandwich of its monocoque shell. Elliptical in cross section, it was formed in two separate mirror image halves using curved molds. Structural aircraft grade plywood is most commonly manufactured from African mahogany, spruce, and birch veneers that are bonded together in a hot press over hardwood cores of basswood or poplar or from European pitch veneers throughout. Basswood is another type of aviation grade plywood that is lighter and more flexible than mahogany and pitch plywood but has slightly less structural strength. Aviation grade plywood is manufactured to a number of specifications, including those outlined since 1931 in the Germanischer Lloyd Rules for Surveying and Testing of Plywood for Aircraft and MILP 607, the latter of which calls for shear testing after immersion in boiling water for 3 hours to verify the adhesive qualities between the plies meets specifications. Aircraft grade plywood is made from 3 or more plies of which as thin as 0.4 mm thick in total and is extremely strong and light. Howard Hughes H-4 Hercules was constructed of plywood. The plane was built by the Hughes Aircraft Company, employing a plywood and a resin Duramold process. The specialized wood veneer was made by Rhodes Manufacturing in Marshfield, Wisconsin. And then it is also used in decorative as overlaid, usually faced with hardwood including ash, oak, red oak, birch, maple, mahogany, shorio, often called Lowayon, Meranti, or Philippine mahogany, though having no relation to true mahogany, rosewood, teak, and large number of other hardwoods. And this plywood, flexible plywood, is designed for making curved parts, a practical which dates back to 1850s in furniture manufacturing. At 9.5 mm thick, mahogany 3-ply wiggle board or bendy board come in 4 by 8 feet sheets with a very thin cross grain central ply and two thicker exterior plies, either long grain on the sheet or cross grain. Wiggle board is often glued together in two layers once it is formed into the desired curve so that the final shape will be stiff and resist movement. Often decorative wood veneers are added as a surface layer. In UK, single ply sheets of veneer were used to make stovepipe hats in Victorian times, so flexible modern plywood is sometimes known there as hatter's ply, although the original material was not strictly plywood but a single sheet of veneer. Marine plywood is manufactured from durable face and core veneers with a few deficits, so it performs longer in both humid and wet conditions and resists delaminating and fungal attack. Its construction is such that it can be used in environments where it is exposed to moisture for longer periods. Each wood veneer will be from tropical hardwoods and have negligible core gap, limiting the chance of trapping water in the plywood and hence providing a solid and stable glue bond. It uses an exterior weather and boil proof glue similar to most exterior plywoods. This marine plywood can be graded as being compliant with BS 1088, which is a British standard for marine plywood, and IS 710 is Bureau of Indian Standards BIS for marine grade plywood. There are few international standards for grading marine plywood and most of the standards are voluntary. Some marine plywoods has a Lloyd's of London stamp that certifies it to be BS 1088 compliant. Some plywood is also labeled based on the wood used to manufacture it. Examples of this are Okume or Meranti. In UK, one can find builders merchants advertising a grade of ply as marine ply that does not conform to BS 1088. Generally, online adverts for these products will include a caveat along the lines of not suitable for boat. And some other types of plywoods include fire retardant, moisture resistant, wire mesh, sign grade, and pressure treated. However, the plywood may be treated with various chemicals to improve the plywood's fireproofing. Each of these products is designed to fill a need in industry. Baltic birch plywood is a product of an area around the Baltic Sea. Originally manufactured for European cabinet makers but now popular in the US as well. It is very suitably composed of an inner void free core of cross banded birch plies with an exterior grade adhesive. The face veneers are thicker than traditional cabinet grade. So now let's see how the locks for plywood construction in a plywood factory is made. Plywood protection requires a good lock called a peeler, which is generally straighter and larger in diameter than one required for processing into dimensioned lumber by a sawmill. The log is laid horizontally and rotated about its long axis, while a long blade is pressed into it, causing a thin layer of wood to peel off, much as the continuous sheet of paper from a roll. An adjustable nose bar, which may be solid or a roller, is pressed against the log during rotation to create a gap for veneer to pass through between the knife and the nose bar. The nose bar partially compresses the wood as it is peeled. It controls vibration of the peeling knife and assists in keeping the veneer being peeled to an accurate thickness. In this way, the log is peeled into sheets of veneer. which are then cut to the desired oversized dimensions to allow it to shrink depending on wood species when dried. The sheets are then patched, graded, glued together, and then baked in a press at a temperature of at least 140 degrees Celsius and at a pressure of up to 1.9 megapascal, that is around 280 psi, but more commonly 200 psi, to form the plywood panel. The panel can then be patched, have minor surface defects such as splits or small knot holes filled, resized, sanded, or otherwise refinished depending on the market for which it is intended. Plywood for indoor use generally uses the less expensive urea formaldehyde glue, which has limited water resistance, while outdoor and marine grade plywood are designed to withstand moisture and use a water resistant resorcinol formaldehyde or phenol formaldehyde glue to prevent delamination and to retain strength in high humidity. The adhesives used in plywood have become a point of concern. Both urea formaldehyde and phenol formaldehyde are carcinogenic in very high concentrations. As a result, many manufacturers are turning to low formaldehyde emitting glue systems denoted by an E rating. Plywood produced to EO has effectively zero formaldehyde emissions. In addition to the glues being brought to the forefront, the wood resources themselves are becoming the focus of manufacturers due in part to energy conservation as well as concern for natural resources. There are several certifications available to manufacturers who participate in these programs. Program for the endorsement of forest certification, Forest Stewardship Council, Leadership in Energy and Environmental Design, Sustainable Forestry Initiative, and Green Guard are all certification programs that ensure that production and construction practices are sustainable. Many of these programs offer tax benefits to both the manufacturer and the end user. The sizes are most commonly used. Thickness range is from 1 by 8 to 3 inches. The size of the most commonly used plywood sheets are 4 by 8 feet, which was first used by the Portland Manufacturing Company, who developed what we know of as modern veneer core plywood for the 1905 Portland World Fair. A common metric size for a sheet of plywood is 1200 by 2400 mm. 5 by 5 feet is also a common European size for Baltic birch ply and aircraft ply. Sizes on specialized plywood for concrete forming can range from 15 by 64 to 13 by 16 inch, and a multitude of formats exist, though 15 by 750 by 1500 mm is very commonly used. Aircraft plywood is available in thickness of 1 by 8 inch and upwards. Typically, aircraft plywood uses veneers of 0.5 mm thickness, although much thinner veneers such as 0.1 mm are also used in construction of some of the thinner panels. Now let's see some applications of this plywood. Plywood is used in many applications that need high quality, high strength sheet material. Quality in this context means resistance to cracking, breaking, shrinkage, twisting, and warping. Exterior glued plywood is suitable for outdoor use, but because moisture affects the strength of wood, optimal performance is achieved where the moisture content remains relatively low. Sub-zero conditions do not affect the dimensional or strength properties of plywood, making some special applications possible. Plywood is also used as an engineering material for stressed skin applications. It has been used for marine and aviation applications since World War II. Most notable is the British de Havilland mosquito bomber with a fuselage made of birch plywood, sandwiching a balsa core and using plywood extensively for the wings. Plywood was also used for the hulls in the hard chin motor torpedo boats and motor gun boats built by the British Power Boat Company and Waspers, American PT boats, and the Higgins landing craft critical to the D-Day landings. The American designers Charles and Ray Ames are known for their plywood based furniture, as is Finnish architect Alvar Aalto and his firm Artec, while Phil Bolger has designed a wide range of boats built primarily of plywood. Jack Hofer of Capstone designed the plywood Dapchick sailing dinghy, which as of 2015 is still sailed by large numbers of teenagers. Plywood is often used to create curved surfaces because it can easily bend with the cranes. Skateboard ramps often utilize plywood as the top smooth surface over bent curves to create transition that can simulate the shapes of ocean waves. Soft plywood typical end use of spruce plywoods or floors, walls and roofs in home construction purposes and in wind bracing panels and in vehicle internal bodyworks, packages and boxes and in fencing. There are coating solutions available that mask the prominent grain structure of spruce plywood. For these coated plywoods, there are some end uses where reasonable strength is needed, but the lightness of spruce is a benefit. It is used in concrete shuttering panels and ready to paint surfaces for construction. The hardwood plywood is used in phenolic resin film coated film face hardwood plywood, which is typically used as a ready to install component like panels in concrete, formwork systems, floors, walls, and roofs in transport vehicles, container floors subject to heavy wear in various buildings and factories, and scaffolding materials, wire or other styles of imprinting available for better traction. Birch plywood is used as a structural material in special applications like wind turbine blades, insulation boxes for liquefied natural gas carriers. Smooth surface and accurate thickness combined with the durability of the material makes birch plywood a favorable material for many special end uses like high-end loudspeakers, die cutting boards, supporting structure for parquet, playground equipment, furniture, signs and fences for demanding outdoor advertising, musical instruments, and sports equipment. Tropical plywood is widely available from the Southeast Asia region, mainly from Malaysia and Indonesia, which are commonly used as concrete panel, floor base, structural panel, container flooring, laminate board, and laminated veneer lumber. So, it's a large thing about the plywood. So, when you see this plywood next time, you get astonished how hard it is, how it is hardly made out of. It has a various history and chemistry behind it. So that's it for today's video about what this chemistry behind this plywood. If you have any science related queries, you can kindly ask it and get it rectified through this channel. We will meet in the next Science Fact Treasury series. Until then, it's goodbye from Sam. Take care.